today we are going to be transforming logarithmic and natural log functions. Okay, so we have the graphs of the common and natural logarithmic functions. Now remember, for common, your base is 10, they don't write it. For natural, your base is e, even though they don't write it. Okay? So there's your logarithmic function in blue, and there's your natural logarithmic function in red. Alright, so what we do to get our transformations is if they're logging something and they're adding or subtracting with the x, then it's going to move left or opposite. I mean, if they're adding, it's going to move left, yeah? But adding or subtracting left or right. If they're multiplying the x by a negative on the inside, that's going to reflect it over y, which would turn it this way, okay? If you have a number minus x, you've got two things, and this is actually wrong, okay? So the x being negative is going to make it reflect across y, but this is actually going to move it right. And you're going, Miss, you wrote left, because yeah, I was thinking, well, that's positive. But remember, when x is negative, then if you factored out a negative, that would change its sign. So that actually makes it go from being the opposite to the actual real, okay? If the negative's on the outside, that's going to reflect over x, which would turn everything upside down. Okay, so if you turn this upside down, I don't draw very well. I can't draw it upside down. I think it would do something like this, yes? Alright, and if you add or subtract something to the log on the ground, then that's going to move it up or down. Same with your ln, your natural log function. Alright, so it says, first of all, we're just going to describe how to transform the graph. We don't actually have to graph it yet. Well, this positive 3 on the inside is going to move it left 3. So if I just kind of sketch the natural log, I don't know which one the natural log looks like. That was the red one, so it doesn't touch right there, so it comes up like this. So there would be mother, and then 3 units left would do something like this. Let's see how close I am. Oh, look. Except for it only goes down so far. Okay, and it moved it over 3 units. Alright, that negative on the inside is going to reflect over y, which means it's going to turn it this way. And the positive 3 means it's going to move it up 3. And if I look at the graph, sure enough, it turned it, reflected over y, and moved it up 3 units. Okay, this one's going to be the tricky one. That negative is going to reflect over y. This positive 2 would make me think go left 2, but because x is negative, that's going to reverse it and actually make it go right 2. And if I looked, it reflected over y, so it turned it this way, and then it went right 2 instead of left 2. Okay? Alright, so if we do this one, the negative 1 is going to move it down 1. So if I take my log function and move it down 1, there you go. This negative on the outside is going to reflect over x. The 2 is going to be a vertical stretch. And the negative on the inside is going to reflect over y. So there would be the logarithmic function. Reflecting over x would turn it upside down, which would do this. And then reflect over y would turn it this way. So now we're doing this on this side, and I don't draw very well. And it's going to be a vertical stretch, so it's going to be steep. Let's see. And there we go, except for I'm steep the wrong way. Okay, so there it is. Alright, this one, the times 2 on the outside is going to be a vertical stretch. This negative on the inside is going to be a reflect over y. This positive 3 would make it go left, but because of the negative x, it's going to go right 3. And the minus 1 is going to make it go down 1. Okay? And if we looked, Okay, my logarithmic does this, but I reflect over y, so it turns it backwards. And then it went right 3 and down 1, right? And so it does this. Alright, so you do this one, hit pause, come back when you're ready. Come on, and hopefully you got 3. This 5 is going to be a vertical stretch. The minus on the inside is going to be reflect over y. The positive 4 would be 4 left, but it's actually going to go 4 right because of the negative. Okay, and there's your graph. Do this one. Hit pause, come back when you're ready. And hopefully you got 4. Alright, this negative on the outside is going to reflect over x. The positive 3 on the inside is going to go left 3. So 3 units left, reflect over x. Okay, so it was doing this, it turned it upside down and went like this, and then it moved it left 3, so it moved it that way. Alright, so now to graph more accurately. Well, we need our mother points. Okay, remember these two are inverses to each other. Okay, this would be an exponential function, this would be a logarithmic function. They are inverses to each other. The mother points of the common log are 0.5, negative 0.3, 1, 0, and 10, 1. And how I got that is, you can do this on the calculator because it's base 10. So I just did log of 0.5 and got negative 0.3. Actually, what I did was I just graphed it and I went to the table and got some ordered pairs that looked decent. Okay, but you could do it by plugging it in. Your mother points of the natural log function are 0.5 and negative 0.7, 1, 0, and 2.721. Notice that your base is here. The base 10, right? So it's going to go through 10, 1. For natural log, it's base e, so it goes through e, comma 1. Okay? And then we're going to do the math like we've always done. All right, so it says, describe the transformations and graph the function and the mother function. All right, well, the mother function would be the common log, ln of x, and it has mother points at 0.5, negative 0.7, 1, 0, and 2.72, 2.72, comma 1. So there's mother natural log. Okay, so now we're going to describe our transformations. I have this positive 2 on the outside, which is going to move it up 2, which means I add 2 to my y's. Then I have two things happening to x. I have the negative on the inside, which is going to reflect over y. And that means I'm going to divide my x's by negative 1, because they're telling me to multiply by negative 1. And then the 3, the positive 3, remember we would think would go left 3, but because x is negative, it's going to make it normal and go right 3, which means I take my x's and but I'm actually going to minus 3 from them. But it's going to make a shift go right because of this negative 2. Okay, so if I've got two things happening to x, I have to do them in Asmodep order. And one thing happening to y, I do in PEMDAS order, although it doesn't matter because it's only one thing. So if I take my mother points, 0.5, negative 0.7, 1, 0, 2.721, and I do the math. If I do my y first, I'm going to add 2 to my y's. That's going to give me 0.5, comma, and negative 0.7 plus 2 would be 1.3. This is going to be 1, 2. This is going to be 2.723. And that's done. So now I'm going to do the others. I have to do those in Asmodep order. So the first thing I'm going to do is subtract 3 from my x's. And that's going to give me negative 2.5, comma 1.3. negative 2, 2. 2.72 minus 3 is negative 0.28, comma 3. So that's done. And now I have to divide by, what color did I do that in? Now I have to, oops, I did the wrong color. Now I have to divide by negative 1, which is going to give me 2.5, comma 1.3, 2, comma 2, and positive 0.283. So if I plot my new ordered pairs, 2.5, 1.3, 2, 2, and 0.283. And it's going to do, what did we do? We reflected over y, so it's going to turn this way. Yeah, and it moved up 2. And pretty darn close. Yeah? See how it crossed that 0.3 approximately? I'm pretty close there too. Alright. So now let's do a common log. The common log mother points are 0.5, negative 0.3, 1, 0, and 10, 1. So if we describe our transformations, we've got this times 3 on the outside. That's going to be a vertical stretch. Nothing's happening to x because nothing's inside parentheses with x. If that was the case, then we would go right 2, but it's not, so that minus 2 is actually going to go down 2, which means everything's happening to y, which means we do PEMDAS, which means we're going to multiply by 3 first. So I take my mother points. Oh, we didn't graph mother. Let's graph mother. Mother is going to be at 0.5, negative 0.3, 1, 0, and 10, 1. Oh, crap. All right, make a big enough graph. 2, 4, 6, 8, 10, 1. Let's count by 2s, which means 0.5 is going to be right there, and 1, 0 is going to be right there. So this is my logarithmic function, and we're counting by 2s. Okay? Alright, so now let's do the math. So we have 0.5, negative 0.3, 1, 0, 10, 1. And first thing I'm going to do is multiply my y's by 3. That's going to give me 0.5. And if I do negative 0.3 times 3, oops. Negative 0.3 times 3, I get negative 0.9. This will be 1, 0. This will be 10, 3. And that's done. So now I have to minus 2 from my y's. That's going to give me 0.5. And I got negative 0.9 minus 2 is going to be negative 2.9. So 1, negative 2, 10, 1. So if I plot those new ordered pairs, 0.5, negative 2.9, and I didn't count by, so that's going to be about right there, 1, negative 2, 10, 1. Okay, same thing. So it's going to be that, and that's because of the stretch. Mark it okay? Alright, you decide which function this is. Just look at how it moved. Obviously it's the natural log function, so picture where it is, which is like right here. Alright, and then see what they did. Did they move right, left, up, down? Hit pause, come back when you're ready. And they went to the left 3. Which means they added 3 to the x on the inside. Do this one. Hit pause, come back when you're ready. Okay, this is, your mother would be common log, which does this, right? So they reflected it over y, which means my x has to be negative. Yeah? You're going to have a negative x. Well, the only one that has a negative x is this one. It didn't turn it upside down, so that's got to be the one that it is. Plus, it moved 4 to the right, which I would have expected left, but because of that negative, it does move it right. So it's got to be 1. Okay? All right, now find a natural logarithmic regression equation. Whenever you see regression equation, they're telling you to go to stat and enter data. So I'm going to go to stat, and I'm going to enter my data. Now notice how I put 10, 20, and 40 in for L1 instead of 1969. And that's because you don't want to use the 4-digit year. Okay? It's got, it says assume that t equals 0 is the year 1950. So if 1950 is 0, then 1960 is 10, 1970 is 20, and 1990 is 40. And then I put my y values in for L2. And I go to second calculate, and I want, it says to make a natural logarithmic, a natural logarithmic regression. And do you see this choice 9 where it's got ln reg? That's the one you're going to pick, okay? And it will give you I'm an idiot. I didn't do a natural logarithmic regression. I did an exponential regression. Oh, Tamsin. You're so silly. All right. Hold on. I'll hit pause here and fix this. Okay. So I think I fixed it. Sorry, I totally picked the wrong regression equation. So let's start over. So we're going to go to stat, and again, we're going to type in the 10, 20, and 40, and the y's in L2. Here's where I screwed up. So you're going to go to stat, arrow over to calc, and I want the ln reg, okay, for the natural log regression. Okay, so then you hit enter and enter and enter, and how many ever times, and it comes up with this. So my function would be f of x equals negative 85.7 plus 43.03 ln x. So if you type, now to solve this, okay, it wants to know, use it to estimate the production level for the year 1985. We can do it graphically, but let's do it algebraically first. In 1985, from 1950, to figure out how many years from 1950 that is, we would subtract, and that would give me 35. So since x represents the year, they're telling me to replace x with 35. So to find the value of the function at 35 years, it would be negative 85.7 plus 43.03 times ln of 35. And the calculator understands natural log. So if you type in negative 85.7 plus 43.03 ln 35 and hit enter, you get f of 35 is approximately 67.3 million. You could do this graphically or with a table of values. You could go and set your table to start at 35, count by ones, and then, well, you'd have to go to y equals, you'd have to go to y1 and type in this function, and then you could set your table and go to table, and you would see at 35 years it's 67.279, which is rounded 67.3 million. Yeah? Okay. So, do this one. Again, you're going to go to stat, plug in your data, and find a natural logarithmic regression. Okay, so hit pause, come back when you're ready, and let's see if I screwed this one up. Oh, good, I picked the right one. See, I picked linear regression this time. Yay. All right, so we get this function, which would give me y equals negative 3.22 plus 2.04 ln x. All right, so then it wants me to figure out, if I do it algebraically, I want to know what would it be when x is 15. So if I plug in 15 for x, I have negative 3.22 plus 2.04 ln of 15. And if I type that in, negative 3.22 plus 2.04 times the natural log of 15, I get y equals 2.30442241. Okay, or you could do it at, and they just rounded it to 2.3, or you could do it in the table, but you'd have to type this in for y1 and then go to table at 15 and you would get your answer as well. Alright, so we've got this decibels now, this sound intensity, okay? It says the level of sound intensity in decibels. So if you're finding the level of sound intensity, what you're finding is this beta that they're using a Greek symbol for. All right, but apparently that stands for decibels. And what you do is it's 10 times the log of the sound intensity of whatever you're looking for divided by the threshold of human hearing, which is the quietest audible sound intensity. So it says find the decibel level for a subway train. All right, well, for a subway train, it's telling me that its intensity is 10 to the negative 2. So what I do is I set this up. I'm finding the decibel level, which is going to be 10 times the log of the subway train's intensity, which is 10 to the negative 2, over the I sub naught, which is the smallest, the human hearing threshold, which is 10 to the negative 2. So if I simplify inside, I would have beta equals 10 times the log of 10 to the negative 2 minus a negative 12, right? Because when you divide, you subtract exponents. So negative 2 minus, that's going to turn positive, and that's going to give me that it equals 10 log 10 to the 10. And you see how now these match? We can use our properties of logarithms and go, well, this is going to make 10. So now I have 10 times 10, which gives me a decibel level of 100. Okay? And I think I did it on the graph. I did. I typed in this function, and I went to table and looked at, I tried to find, why did I look up 0.01? I don't know why I looked up 0.01. Anyway, you can do it algebraically. Alright, so now it says find the decibel level for a sound that produces this intensity. So if I set that one up, I would have my decibels are equal to 10 times the log of 2.75 times 10 to the negative 4th divided by 10 to the negative 12. If you do this math, okay, this is really 1 times 10 to the negative 2nd. So if I divide this out, my parentheses, I'm going to have my decibels are 10 times the log. 2.75 divided by 1 is 2.75 times 10 to the negative 4 minus a negative 12 is going to be 8. Now, this one we can't do like we did this one. This one we could divide that out and we would get 10 to something, which is why these canceled. I can't do that here. We've got 2.75 times 10 to the 8th. If the 2.75 wasn't there, then the 10s would cancel and I'd get 8. But it's there. So you have to type it in a calculator. You literally are going to type 10, then you're going to hit the log key, and it's going to open parentheses. So you type 2.75 times 10 caret 8, close your parentheses, and hit enter. And you should get, let me check it just to make sure, 10 times log 2.75 times 10 caret 8, close it, and you get decibels are 84.4 if you round. Okay, or I could go graphically, and I typed this function in, and I went to look at 2.75 e to the negative 4. I just set my table to do it, and I get the same answer. Alright, so you do this one, hit pause, come back when you're ready. And hopefully you got 75. If not, let's look at y. So it says it's giving me the sound intensity of some noise. So that's going to go on top. All right, so we're going to have beta equals 10 times the log of 3.14 times 10 to the negative 5th over 10 to the negative 12. This is like 1 times that, so that's going to give me the decibels are 10 log. 3.14 divided by 1 is 3.14 times 10 to the negative 5 minus a negative 12 is going to be 7. Type that in a calculator and you should get 75. Let me check. 10 times log 3.14 times 10 caret 7. Yep, you get 74.9692 blah 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 blah, and they rounded it to 75. Alright, so if we look at this one, it says wind speed varies in the first 20 meters above the ground. For a particular day, let f of x equals 1.71 natural log of x plus 5.2. Compute the wind speed. So this is wind speed. That's what it computes. X is the height, basically, above the ground. So it's asking me at what height, so they're asking me to find x if the wind speed is 6. So they're telling me to change this side to 6. So I have 6 equals 1.71 natural log of x plus 5.2. So to solve this one algebraically, we've got to get x alone. So what we're going to do is we're going to isolate it. So I'm going to subtract 5.2, and I get 6 minus 5 should be 0.8, right? 0.8 equals 1.71 natural log of x. So next thing I'm going to do to isolate is I'm going to divide by 1.71. Divided by 1.71, I get 0.46783625. You can round, but I always wait till the end. Equals the natural log of x. Now, to solve this, we're going to use our properties from yesterday. I want to get the natural log away, so you're going to roll it. But remember, what the base is e. So the natural log rolls, and e moves over. Okay, when the log rolls over, the base moves over. So I have e caret 0.47 equals x. So if I type that in, I literally type e, which is second divide, caret 0.47, enter. You know what, I'm not going to round so much. I'm going to do second divide, caret 0.46783625. The less you round, the more accurate your answer is. Wasn't that much difference. Anyway, I get x equals 1.59653596. And what does it say? We round results to the nearest hundredth. 10th hundredth, 6 is going to bump that up to 0, which bumps that up to 6, which gives me x equals 1.60. Which means it would be 1.6 meters above the ground. Alright, and you could also have solved it algebraically. Graphically. If I typed this in for y1 and this side in for y2 and calculated the intersection point, I get the 1.596 blah 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 blah, which rounds to 1.6 meters. Okay? Alright, so you try this one. Hit pause, come back when you're ready, and hopefully you got 3. Alright, so again, same exact question, but they give me a wind speed of 9, so we set f of x equals to 9, 4.51 ln x plus 6.5. So to solve it algebraically, I would subtract 6.5. 9 minus 6.5, I get 2.5 equals 4.51 natural log of x. Divide by 4.51. Divided by 4.51, I get 0.46783625. 0.5543237 equals the natural log of x. Roll the natural log. When the log rolls over, the base moves over, so I have e to the 0.5543, I'm not going to write it all, equals x. So to get my x, I type that in, e caret 0.5543237251, and I get 1.74076, blah, 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 blah. And again, their rounding must have been different than mine because they rounded to 1.75 and I would have rounded to 1.74. It's rounding. Alright, or you could have typed this in for y1 and this side in for y2 and calculated the intersection point. And my answer is more accurate than his. Alright, so it says using graphing calculator to sketch a graph of f of x and g of x. So just type this in for y1 and type this in for y2, except for you don't know how, darn it. To type this in for y2, you're going to have to do a change of base formula, which I haven't taught you yet, but let me just tell you how to type this. To type g function in, you would type log of x divided by log of 0.1. So I guess actually it's not going to type like that. You would do log x divided by, and I would put these in parentheses, log 0.1. Type that in for y2, that in for y1, and I want you to decide and look at y. This is base 10, this is base 0.1, which is part of 10, yeah? Alright, so just explore that and give me your thoughts. Alright, so we are at homework, which means we are done. So happy homeworking, and I will see you next time.